All right, to finish up chapter 2, I'm going to talk about section 2.6, absolute value equations and inequalities. So you did see this earlier on a handout. I said this thing about to really understand a function, you should know how to free the argument. Now the author writes something like this, equations involving absolute value. If a is a positive real number and u is an algebraic expression, then the absolute value of u equals a is equivalent to, and then he writes this out. All right, this is true, but what are we actually talking about when we say u? What we're really talking about is the argument of an absolute value function. So I don't disagree with what the author is saying here, but I think he's really missing an opportunity to start talking about this concept of the argument. So what the author writes here, I wrote here, and that is, if the argument is absolute value of an argument is equal to k, you can free the argument with this line here. Argument is equal to minus k, or the argument's equal to k. And there are two others. If the argument, absolute value of an argument is less than k, then this is the pattern that frees the argument. Minus k is less than the argument, it's less than k. And then if the absolute value of an argument is greater than a number, by the way, k is positive in all of these. We'll talk about negatives in a minute. And then this would be the pattern that frees the argument. Argument is less than minus k, or the argument is greater than k. So let's put those to work with some examples. I have this example, example 2. Let me cover it up. Sorry. So we can reveal it just one step at a time here. This is my handwritten version of example 2. And notice it doesn't really fit any of these previous rules I put up here. It's pretty close to this one, argument equals k, but it's got that 3 there. And so I want to add or subtract 3 from both sides. And that actually gives me exactly what I was looking for. Something of the form, so this is of this form right here, argument equals k, or 2x plus minus 1, absolute value of 2x minus 1 equals 9. So what's the pattern that frees the argument? Argument equals minus 9. So understand that I had a plus 9 here, but it does become a minus 9 when I free the argument. So I set the argument equal to minus 9. I set the argument equal to positive 9. And I proceed to solve for the argument. Just solve for x. And we get x equals negative 4 and x equals 5. So that was example 2 where we were applying this rule here. You just have to see the problem to tell which one you're applying. Example 6. Absolute value of some argument is less than some k. And so we're going to apply the rule, this rule here, to this equation. The argument no longer has an absolute value on it. The only real change I had to do was tack on this minus 5 is less than or equal to the argument. Notice it has 3 parts to it, so I'm going to subtract 3 from all, the left part, the right, and the middle. And I'm going to keep this together as a combined inequality. So I get this, I get negative 4 is less than or equal to x is less than or equal to 1. And that really is the final inequality. The only thing I want to do is put it in interval notation. And now the last problem was not an interval because we're dealing with equalities. But this one is an interval because we're dealing with a minimum and a maximum. So the minimum is negative 4, maximum is 1. That's the way I'd wrap it up in interval notation. All right, let's get a chance to use this last one. So hopefully you remember it. Absolute value of an argument greater than k, and that's how you free the argument, but I wrote it down. on this paper just the same. So when I saw example 9, I just decided to write this way of freeing the argument down so we could have it right on the same page. All right, so this one, how do you free the argument for a greater than? It is the argument is less than minus k. So just so you see it. Oh, I need to add a minus sign to my what I copied here. And my pen doesn't work. All right. I had it correct on the other one, but it is a minus sign there. So this positive 3 becomes a minus 3 when we free the argument. And again, this is just a pattern you need to know to fully understand absolute value. Solving each of these, I solved them together here on the same lines, but anyhow, you solve this and you get, this is your final inequality. X is less than 1 or X is greater than 4. I decided to draw this. What does it mean when we say X is less than 1? It means all the numbers that are less than 1. So 0, negative 1, negative 2, negative 3. And that pattern goes to negative infinity. And then X is greater than 4 means 4, 5, 6, etc. Putting all that together into an interval, this would be the interval we have. Now I lightly circled the thing because the answer is the whole thing. It's not just one part of that. The answer is these two intervals on the number line. All right, now there's a couple of things I didn't mention when I first did this. I skipped a few examples. I skipped any example with a minus k. So I like to say this. Think of minus k as a stop sign, as in stop and answer the question without doing any steps. So I'm looking at this problem right here. Absolute value of 3x plus 5 is equal to minus 6. Not 6, but minus 6. There's really no steps. The absolute value, the way of freeing the absolute value before doesn't work, or freeing the argument doesn't work. You just have to stop and answer the question. When is something with an absolute value on it equal a negative number? Well, it never is. So since that's never true, we just say the answer is the empty set or no solution. How about if we have the absolute value of an argument is less than negative 6? Well, less than a negative number, this can't happen either. Again, you just have to think about this. When will absolute value of anything be less than a negative number? Think of a number less than negative 6, like negative 10. An absolute value can't be that, can't be any of those negative numbers. So again, the answer is just no solution. Stop and answer the question. No steps, just you have to answer the question. This one's different. This one's saying, when is the absolute value greater than a negative number? This is always true. Anytime you take the absolute value, you're going to get 0 or higher. And 0 or higher is always greater than a negative number. So the way we answer that usually is with interval notation, negative infinity to infinity. All right, that is not the end of 2.6. You might notice that 2.6 really is the majority of this section. It really does cover pretty much everything moving forward. And we had a few important things in earlier in chapter 2, but really 2.6. All right, here's one I haven't given you yet. What if you have the absolute value of argument 1 equals the absolute value of argument 2? Well, you free the arguments with this pattern here. Argument 1 equals minus argument 2, or argument 1 equals argument 2. So again, freeing the arguments. So I'm doing that with example 4 right here. So with example 4, you see the two absolute values. It's an equal sign. Well, we have two arguments. The first argument is 2x minus 3. The second argument is x plus 6. So this is my freeing the argument all in one line. Argument 1 equals minus argument 2, or just argument 1 equals argument 2. I solved these two separately. So look at the long one first. Look at this one first. I had to distribute the minus sign. I wanted to cancel the x and on this side and the 3 on this side, and that gave me 3x equals -3, and eventually I got x equals -1 from that part of the solution. Now let's focus in on this one. Solving this one, it solved really quickly. I added x or subtracted x, added 3, it just kind of popped out to be x equals 9. So those two things I circled, that's the answer. Again, this is not an interval. This is just two numbers. One of them is x equals -1, and the other one is x equals 9. All right, that is section 2.6. And I can't say that absolute value plays a big role in moving forward, but this idea of being able to free the argument is an important idea. Now, before I kind of end this all here, like I said, the author doesn't seem to have my affinity for the word argument. The author wrote everything I said in the summary here, but if you just changed U into argument, this would be exactly what I have on my page. The absolute value of any argument is equal to A, means you just set the argument equal to those things. So all of this is what I call freeing the argument. All right, that's section 2.6, and that means that's chapter 2. So I'll upload some videos for the other chapters later, but keep working on the My Math Lab, and I hope these examples are somewhat helpful. But again, the only questions I can ask, I'll say it this way: in past semesters, I've been able to take something like this and type it onto a test, just to force students to, or reward students, I guess, to study the examples. Well, there might be something very similar to this on the website, but it won't be this exact problem. So how do you know the exact problems that I can put on the exams? You'll know them by doing the homework. So just want to emphasize that one more time. By the way, if you were following along a little too closely, you might have noticed that I'm using a different edition of the book. I happen to have the 3rd edition. Online, it's the 4th edition, so the page numbers might be off a little bit, but I think the example numbers are fine. Anyhow, that's the end of chapter 2, and we'll move on to another chapter, so keep looking for more videos. Thank you. Bye.